Hi, I'm Stevie C and the place to be. In a previous video, I showed how I designed and built an LED sign for a local shop based on 595 shift registers driven from a PICAXE. This is one of 4 remaining from the small batch from JLC PCB, and as you can obviously see, it's a bit big, so not great for importing a ton of or mailing out to people. So I did my usual, twice over in fact. First, I revisited the design and shrunk it down to a much smaller and scalable display card, which drove the LEDs directly from the shift registers. I didn't make a video about this, mostly because I was already working on another version when this was being manufactured. Although smaller and therefore much cheaper to import and hopefully mail to customers, it suffers from a similar design flaw. Namely, that once populated with LEDs to spell what you want, in this case dses.uk, that's it stuck saying that forever, unless you desolder and resolder the LEDs. For example, if you got the domain wrong and needed to spell dses.tv instead. Also, the number of characters per PCB may not match the message you want to display. In this instance, I want it to spell audio wave, but there's a problem. I now need another card to complete the name. And then there's tons of dead space. Yes, I could add .co.uk, but you know what I mean. So I designed another new version. These are derived from my Das Voltzeichen single-letter LED PCB panels, which are of course inspired by Big Clive. Each PCB, or character card if you will, has positions for 5 shift register ICs, one for each column of the LED letter, which measures 7 by 5 pixels. So there's one unused output. More on this later. And yes, I had the PCB manufactured in black as opposed to spray painting it myself this time. So you can hopefully see an advantage with this design. You only buy as many PCBs as you want displaying your message at one time. You can then code your processor to either scroll the text smoothly, scroll it a letter at a time, or have it constantly displayed. So, first up, I'm soldering these wire links which connect the serial clear pins to the bus bar. Next, the LED matrix resistors, which I'm putting on the reverse of the PCB for neatness. And then the power supply diode. Then the shift register ICs. And then the LEDs. And then the interconnects. And finally, the voltage regulator circuit. Each card has the option to install a 5-volt regulator or a wire link to pull 5 volts from the previous PCB in line. Capacitors are recommended either way. Each card passes through the 12-volt supply, from which the 5-volt rail is derived, to help minimize voltage drop across the run of PCBs. I'm using these right-angled PCB interconnects for the application. It's kind of a pain that I can't find 8-way sockets, so basically you just work out how many LED PCBs you can drive from one regulator, and maybe tweak your resistor values accordingly. In this video, I'm using 470 ohm resistors, which on the 5-volt supply should run a panel of white LEDs at about 140 milliamps for the whole card, in theory. Here's a bit of classic Stevie C design for you. I've sourced a 2-amp 5-volt regulator, but the diode feeding it is only rated for 1 amp. Oh well. So now it's just a case of assembling more PCBs. On to interfacing. I designed this AIO PCB for use with the fixed lettering PCBs. As you'll see, it has positions for switches, 555 timers, PICAXEs, and even piezo shift input. Basically all the ways I'd ever want to drive shift register displays. I could use an Arduino or a Raspberry Pi, but I prefer writing everything myself, so PICAXE is what I'll be using here. And I've designed it to be compatible with a 08M2 and a 14M2 PICAXE processor due to the same pin configuration. As you can see from the interconnect alignment, the AIO board will work with the new single character PCB. It'll just look a bit out of place, because I didn't consider this during the design stage. Something else I should probably mention, I have no idea why, but I threw random 10k resistor values across the switches, not realizing this creates a voltage divider, and on the 5V supply, two equal resistors give a 2.5V trigger signal. After it didn't work, and consulting the datasheet, I realized what was wrong, and replaced the top resistors for 100 ohm ones. Perhaps incorrect component values could be a sort of anti-copying mechanism. Yeah, that's what it was. It was intentional. Anywho, moving on. I originally designed the PCBs to link together with these JST-type connectors and cables, but opted to use the same right-angle connectors as on the big clavicle project. So as I've already built the AIO PCB, kind of, let's give it a whirl. So to create a letter, I have to remember to sequence in 8 LEDs worth of data at a time, even though there's only 7 of them. So once I've clocked the data in, I can then latch it to the output. So, on to programming now. So as I mentioned, I'm using a PICAXE 14M2. Here I'm setting up pin declarations, environment variables, and setting the shift register lines to known states. I'm not claiming this is the best way to do it, it's just the way I'm doing it. So in each letter, I'm using a word variable to send 8 bits of data for the 7 LEDs in a column, plus 1 blank to the routine that takes the word variable, masks the rightmost bit, and uses a loop to write the data, 1 LED at a time. For a 0 or blank LED, only the clock is pulsed. For a 1 or a lit LED, both the clock and serial data lines are pulsed. Once a column has been written, the data is then latched so it can be seen on the LEDs. The subroutine then loops back to the second column of the character, and so on and so forth. I thought I was being clever until I got this compile error. Turns out I'd forgotten how many go-sub commands I could use. The maximum is 255. This led to me writing stuff like blank spaces or solid fills directly without passing data into different subroutines. Obviously, if your message didn't contain the letter Y or the number 6, these could be removed, giving 10 more go-subs to be used elsewhere. So let's see how I got on after clicking the magic button, ejecting the chip from the breadboard, and installing it into the PICAXE PCB, which you've not explained. I've just realized at this point I've not shown this before. I just decided to design and add this onto another order, and had it manufactured in purple because reasons. It wasn't brilliant. The first problem was this corruption between panels. I played about with the code a bit, swapped the interconnects for wires, but couldn't get it to work. I took it to a party I was supplying lights for, and it kinda sorta did the do, but not brilliantly. Some letters were much worse off for data corruption than others. The second problem was during debugging, when I noticed the PICAXE was receiving up to 7 volts instead of 5. Perhaps the processor was just goosed. I replaced the regulator 3 times, each time getting 7, 9, or 11 volts. I cleaned the flux off, which didn't help. I removed the backfeed diode and the caps, again still got an overvoltage condition. Then, without a regulator present, and therefore no circuit, I was still getting between 0.3 and 4 volts at the PIC supply pins. I uttered the magic words, "Oh f***," and built another PICAXE PCB. I couldn't replicate the fault with identical components, so I've no idea what was going on. And then I thought I might as well have a go at rewriting the software. You can see here I've used more word variables, which reduces the amount of go-sub calls, which also decreases the amount of ROM used, which in turn allows much longer messages to be written. I've also removed the latch update call on every column, as that seems to be what was causing some of the jitteriness. Now the text just updates on every character. It doesn't look as good, but it works much better. So let's see the new and improved code in action. Yeah, so I'm not entirely sure if it was the PCB interconnects causing the corruption issues, maybe due to capacitance or whatever, or maybe something in my code, probably that to be fair, I don't know. What I might do in future is just design a PCB that had, say, 4 or 5 characters on it that were hard linked via the PCB traces. Don't know. And now in pink, just because I can. Anyway, thanks for watching this project. Please consider liking, sharing, and Wait, why don't I get the PCB to say this instead? Un momento, por favor.